All right, I picked a few of the problems from the worksheet to go through. And basically what I wanted to do is kind of pick some of the different types that you had to try to attack. So the first one was number 2. You'll notice on number 2, you've got the log on both sides. So anytime you have that situation or have log on both sides, we want to try to simplify that side as much as possible and then attack it from there. So since we have this 2 out in front, we know that we can move that 2 up to the exponent. So I now have this log base 5 of x squared. Over here, again, I can move up the exponents. Now I have log base 5 of 4 cubed. Now, this is a nice situation because anytime you have a log with a base that matches another log with a base on the other side, essentially those logs are not going to factor in. The only thing we need to have happen now, if the logs are the same, is I need the values to be the same. So I need that x squared to equal the 4 cubed, which is really 64. So I'm going to go ahead and square root both sides. And now technically I get plus or minus 8. But I've got to keep in mind my situation here. And in my situation, originally I was going to do log base 5 of whatever my x value is. Well, if my x value were negative, that means that would be undefined. So even though technically there's 2 possibilities, only the x equals 8 is going to work here. So that's an example where we have the log on both sides. This next example, number 12, is a little different. We have a couple logarithms over here on the left side. We don't have any logarithms on the right side, though. So my goal initially, since I have 2 logarithms here, is I want to simplify this into 1 logarithm. And those 2 logs right now are being subtracted, so I know I can combine them by dividing their values. All right, I've got the log on one side, but not on the other. So I'm going to do a rewrite at this step. So my base is 4. Log equals exponent, so that's 3. And that equals this x squared minus 9 over x plus 3. All right, so now I don't even have to worry about the log part. All I'm worried about is solving this equation. So probably I want to get rid of this fraction. So I'm going to multiply both sides. The 4 cubed is really 64. So I'm going to take 64 times that x plus 3. And that should equal now x squared minus 9 because I wiped out that fraction. So I've got 64x plus, if I take 3 times 64, I get 192. All right, so this is going to eventually be a factoring problem because I have x squareds and x's. So I'm going to get over everything over here by subtracting 64x, and I'll have to subtract that 192. So when I do that, I'm now going to have negative 201. All right, so now I'm going to try to factor this. So I'm trying to factor where I'm going to multiply to get negative 201. I'm going to add to get negative 64. So let me think here. This one takes some guessing and checking, but I find out that I got x minus 67 and x plus 3. And so if those are going to equal 0, that means x could equal 67, x could equal negative 3. But again, I always want to make sure that my values are going to work. And if I plug the 67 in, I'm going to be okay. But if I plug negative 3 in, negative 3 plus 3 is going to be 0. And I know I can't take the log of 0 either. So I end up with only the x equals 67 as a solution. Now, you may have noticed on this one that I could have made my life a little bit easier, because once I did this step here, notice I had x squared minus 9, which really could be factored because it's a difference of squares. Why is that helpful? Well, I could cancel the x plus 3's at this point. So really what I'd be looking at is log base 4 of x minus 3 that equals 3. And this makes my life a lot easier because the base is 4, exponent is 3, that equals x minus 3. And so 64 equals x minus 3, which means when I add 3 to the other side, I get 67. So that one actually could have been simplified earlier, and that would have made it a little bit easier to attack. All right, 15 was a tough one. And I know I'm going a little bit out of order here, but I wanted to do another one where logs were involved. So in 15, we had log base 2 of x, and that was to the log base 2 of x power on that x, and that was equal to 4. Well, even though it looked kind of strange here, we still have a situation where we have an exponent that we could bring down as a coefficient. So here's what I really have. I really have log base 2 of x, because that would be this exponent brought down, times the original log base 2 of x. And that's supposed to equal 4. Well, it doesn't matter if I'm dealing with logs or what I'm dealing with. If I take something times itself, what I really have is log base 2 of x, in this case, squared. And we know we can get rid of a squared by square rooting. And so now I can find my solution. 2 was my base, 2 is my exponent, that equals x. So I find out that x is equal to 4. Now you may be asking, when I do that square root, what about the negative? Well, in this case, if I did a negative here, I'm going to have 2 to the negative 2 power, which is okay. That would be 1/4. But I think if you plug that in, you're going to find out that does not equal 4. So you always want to check your answer. Even though this is defined, it didn't actually work as a solution. So I'm only going to have the one solution on this one. Now, if you didn't get that one, I wasn't too concerned with that. That was more of a challenge problem. And had we been together today, we would have talked about that one together in class at some point. So those are all examples where we already had logarithms in the equation. Let's look at a couple where we're missing the exponents. So on number 7, you had 0.3 to the 1 plus x power, and that's equal to 1.7 to the 2x minus 1 power. Well, anytime we're missing exponents, we said that the best way to try to solve it was to bring it down out of the exponent by doing the log of both sides. So I'm going to bring down the exponent of 1 plus x, and I can do that if I do the log of 0.3. But if I do the log on the left side, I got to do it on the right side. Again, I can bring down the exponent though. So I got 2x minus 1 now times the log of 1.7. All right, from there, I usually go ahead and divide by one of the logs. So I'll take the one on the left. So that leaves me with 1 plus x on this side. Over here, I still have 2x minus 1, and now it's times whatever this decimal value is. So I'm going to punch in whatever the log of 1.7 divided by the log of 0.3 is. And that gives me a negative 0.4407. All right, now it's just a normal equation. Yeah, it has a decimal, but it's still just a normal equation. So I'm going to distribute that to my 2x. So now I've got negative 0.8815x. Two negatives make a positive when I multiply them. Now I want all the x's on one side, so I'm going to add this to the other side. So now I have 1.8815x. I'm going to subtract 1 from the other side. So I have negative, 0.5593. And lastly, I'm going to divide. And my answer here is negative 0.2973. Now, this one I got a negative value, but that's okay because I can always have a negative exponent. That's not a big deal. It's just when I'm dealing with logs, I have to double check that. So if I'm missing the exponent, one of our options is take the log of both sides, because that'll allow me to bring the exponent down and then solve it from there. All right, well, when you looked at number 9, you might have jumped right to the log option. However, we still had other options in the past. And if you notice here, I have 3 for a base here and 3 for a base here. Well, that means I could actually attack this slightly different, because the square root of 3 is really 3 to the 1/2 power. And if my bases are the same, really all I need is for my exponents to be the same. So what I'm going to do is I'm going to try to solve this equation. Well, if I do that, I got to get it equal to 0. And on this one, I don't really like that fraction, so I'm going to get rid of the fraction. I'm going to multiply everything by 2. And that'll be okay, because since I have 0 over here, I'll still have 0 once I multiply by 2. So I'm going to multiply this by 2, this by 2. If I multiply a half by 2, I get 1. And 0 times 2 is still 0. So in a perfect world here, I'd be able to factor this. Unfortunately, I'm not going to be able to factor. So I'm going to have to go with quadratic formula here. So the opposite of b squared minus 4 times a times c would be negative 8 over 2a is 4. And so negative 2 plus or minus the square root of 12 over 4. So I've got two situations. I've got negative 2 plus the square root of 12 over 4. And I got negative 2 minus the square root of 12 over 4. And so now it's just a matter of plugging it in. So 0.3660 and negative 1.3660. All right, so hopefully that helps a little bit. I again try to give you an example of different types of equations that you saw on that worksheet.